Hello students, welcome to my channel. My name is Darshan. I am your maths prof. So in this session we'll be solving few important questions based on this topic HCF and LCM, and these all questions will be paper 4 kind of questions. So that is calculator kind of questions, right? I have already told you, I have already informed you that in IGCSE from starting from 2025 there will be two papers, paper 2 and paper 4. Both will be 100 marks each, and paper 2 will be non-calculator and paper 4 will be calculator. So now onwards we'll have to be careful while solving the questions, whether the question is calculator kind of or non-calculator. Okay, so this is why I have put both the kind of videos in one kind of HCF and LCM. We have seen non-calculator questions. Now in this video I'll be solving calculator kind of questions, so you will get an idea about how kind of the how are the calculator kind of questions. Okay, so let's start. This is the first worksheet. There will be total 3 worksheets here. Okay, first one is little bit basic. See the first question. Write 84 as the product of its prime factors. So here just we are supposed to do the prime factorization of 84. 84 is a prime, it's an even number, so we can just divide it by 2. So you'll get 42. 42 divided by 2 again, that's 21. 21 is divisible by 3, so you'll get 7, and 7 divisible by 7 itself, so that's 1. So 84 is 2 to the power 2, 3 to the power 1, and 7 to the power 1. Clear? See the second question. 525 as a product of its prime factors. Same thing, prime factorization of 525. Because it's not an even number, we'll start with 5 because it ends with 5. It is not divisible by 2. So if you divide it by 5, it is 105. 105 again is divisible by 5, so it is 21. 21 is divisible by 3, that's 7, and 7 times 1 is 7. So this 525 can be written as 3 to the power 1, 5 to the power 2, and 7 to the power 1. You can write these prime factors in any order. You can start with 7 also, 7 raised to 1, and then 5 raised to 2, and 3 raised to 1 also. But it's my habit that I always put all the prime factors in ascending order only. Okay, see the third question. Trams leave Piccadilly to Achilles to Achilles every 9 minutes, and to Didsbury every 12 minutes. A tram to Achilles and a tram to Didsbury both leave Piccadilly at 9 a.m. So here both are leaving at 9 a.m. simultaneously, and one of the tram is leaving every 9 minutes and another will be leaving after every 12 minutes. At what time will a tram to Achilles and a tram to Didsbury next leave Piccadilly at the same time? So here again the question will be either we can go for HCF or LCM. Now I have already given you the simple small layman trick that if the answer you are trying to find, if it is more than the given data, if the answer you are gonna find it's gonna be bigger than the given data, then you go for LCM, otherwise you go for HCF. Now here you know that at 9 a.m. they are gonna leave together. After 9 minutes Achilles will a tram to Achilles will leave, and after 12 minutes tram to Didsbury will leave. So obviously they are not gonna leave together in 12 minutes. The time you are gonna find, it will be more than 9 and 12, right? So that means you are gonna find LCM. So let's find the LCM. Prime factorization of 9 is just 3 square, and prime factorization of 12, because it's divisible by 2, 6 divisible by 2 is at 3, and 3 ones are 3. So 12 is 2 raised to 2 and 3 raised to 1, and 9 is 2 raised to 0 and 3 raised to 2. For LCM we consider the highest power of each factor. So 2 raised to 2 is the highest power of 2, and 3 raised to 2 also. So that will be 4 into 9, that's 36. Okay, so now this means that after every 36 minutes they'll be living together. Okay, they started at 9 a.m. so at 9:36 they'll leave again. So at 9:0936 a.m. they will leave together. Okay, so whenever you are trying to find the number, if it is bigger than the given data, go for LCM. If that is gonna be smaller than the given data, then go for HCF. This is my simple thumb rule. Now this is the second worksheet. See the first question, find the HCF of 90 and 48. So let's do the prime factorization. 90 is divisible by 2, you'll get 45. 45 is divisible by 3, you'll get 15. 15 is also divisible by 3, you'll get 5, and 5 ones are 5. Same with the 48. 48 is divisible by 2, you'll get 24. 24 divisible by 2, you'll get 12. 12 divisible by 2, you'll get 6. 6 again divisible by 2, you'll get 3, and 3 ones are 3. So 90 can be written as 2 raised to 1, 3 raised to 2, 5 raised to 1. And 48 is 2 raised to 4, 3 raised to 1, and 5 raised to 0. Now in HCF we consider the smallest power of each factor. So that's 2 raised to 1 is the smaller power, 3 raised to 1 is the smaller power, and 5 raised to 0 is the smaller power of 5. So 2 3s are 6 and 2 1, so that's 6. Clear? Write 56 as the product of its prime factors. So here we are just gonna do the prime factorization of 56. Same kind, divisible by 2, so that will be 28, divisible by 2, again 14, divisible by 2, you'll get 7, and 7 ones are 7. So 56 is 2 raised to 3 into 7 raised to 1. Find the LCM of 56 and 42. Same, I always use the prime factorization method. So that's divide by 2 and you'll get 28, 2 14, 2 7, 7 ones are 7, and 42 divisible by 2, you'll get 21, divisible by 3, you'll get 7, and 7 ones are 7. Now for LCM, first I'll write them in the product of the prime. So 2 raised to 3, 3 raised to 0, 5 raised to 0, and 7 raised to 1. Similarly 42, that's 2 raised to 1, 3 raised to 1, there is no 5, so 5 raised to 0, and 7 raised to 1. And in LCM we take the highest power of each factor. So 2's highest power is 3, 3's highest power is 1, 5's highest power is 0, and 7's highest power is 1. So 2 raised to 3 is 8, 8 into 3 into 7. We'll do it in the calculator. See, 8 into 3 into 7. Observe it on the left hand side of your screen. I have already put the calculator there. So that's 168. Clear? In non-calculator kind of questions, same kind of LCM question, but you'll find it the way you cannot, you don't need calculator for that. It will be a smaller, multiplication. Here you'll find the bigger multiplication and divisions. See the third question, buses to Acton leave a bus station every 24 minutes, and buses to Barton leave the same bus station every 20 minutes. A bus to Acton and the bus to Barton both leave at the bus station at 9 a.m. So they are both leaving together at 9 a.m. When will the bus to Acton and the bus to Barton next leave the bus station at the same time? So again, same thing. Now you are gonna find the time after which they are gonna leave together. Now obviously after 20 minutes one bus is leaving, and after 24 minutes of the 9 a.m. The second bus is leaving. So till 24 minutes they are not gonna leaving at the same time. So the time you are finding, it will be more than the 24 and 20 both. So go for LCM. Correct? So 24 prime factorization to 12 to 6 to 3 and 3 ones are 3. Similarly 20 to 10 to 5 and 5 ones are 5. So that 24 can be written as 2 raised to 3, 3 raised to 1, there is no 5, so I can write 5 raised to 0. And 20 can be written as 2 raised to 2, there is no 3, so 3 raised to 0 and 5 raised to 1. Now in LCM we take the highest power of each factor. So 2 raised to 3, 3 raised to 1, 5 raised to 1. That's 8 into 3 into 5. Let me do it in the calculator. 8 into 3 into 5. That's 120. So after 120 minutes they are gonna live together. Now 120 minutes is 2 hours, because that's 120 divided by 60, that's 2 hours. So after 2 hours they are gonna live together. So starting at 9 a.m. if you add the 2 hours, it will be 11 a.m. So at 11:00 a.m. they are gonna live together. Clear? See the fourth question, prime factorization of 180 they are asking. So 180 divisible by 2, you will get 90, divisible by 2, 45, 45 divisible by 3, you will get 15, 15 is also divisible by 3, you will get 5, 5 ones are 5. Acha, my mental calculation is little bit faster, so I can do it easily, but if you can't do it that fast, you can use the calculator, because anyway it is paper 4 kind of question, so you can use calculator. So 180, that's 2 raised to 2, 3 raised to 2 and 5 raised to 1. Clear? Okay, so B part is Martin thinks of two numbers. He says that HCF of my two numbers is 6. So obviously the numbers he's thinking about, they are multiples of 6, and LCM of my two numbers is multiple of 15. Okay, so multiple of 15, you see, LCM is not 15, LCM is a multiple of 15, but both the numbers should be multiples of 6. Okay, now tell me what are the multiples of 15. They are 15, 30, 45 and so on. So we are supposed to think about two numbers whose HCF is 6. So both are the multiples of 6, as well as their LCM are either 15 or 30 or 45 and so on. So by trial and error, I got to know that the LCM of, let's say, 12, no, let's take 6 only. It will be easier for us. 6 and 30. If I take the LCM of 6 and 30, I'll get 30. Yeah, right. And it is possible that LCM must be multiples of 15. So 30 is possible. So that means he is thinking about 6 and 30, two numbers. Okay, let's see the fifth question. A is given as a product of primes and B is also given as a product of primes, and we are supposed to find the HCF. In HCF we take the lowest power of each factor. So that's a 5 raised to 4, 7 raised to 1, and there is no 11, so I can write an 11 raised to 0. B is 3 raised to 4, 5 raised to 3, 7 raised to 1 and 11 raised to 1. So in HCF we take the lowest power of each factor, so that's 3 raised to 2, 5 raised to 3, 7 raised to 1 and 11 raised to 0. Now 3 raised to 2 is 9, 5 raised to 3 is 125 and 7 raised to 1 is 7. And 11 raised to 0 is 1 only, so you don't need to consider that. Now let's use calculator. See the left hand side of your screen. I'm doing 9 multiplied by 125 multiplied by 7. I'm getting 7875. So that's the HCF of A and B. Clear? Okay, find the LCM of A and B. So in LCM, what do? We take the highest power of each factor. So let me write A and B again here. So that A is 3 raised to 2, 5 raised to 4, 7 raised to 1 and 11 raised to 0. And B is 3 raised to 4, 5 raised to 3, 7 raised to 1 and 11 raised to 1. Now for LCM, we take the highest power of each factor. So that's 3 raised to 4, 5 raised to 4, 7 raised to 1 and 11 raised to 1. Now let's use calculator. 3 raised to 4, so 3 to the power 4 multiplied by 5 raised to 4 multiplied by 7 multiplied by 11. You are getting 3898125. You see, the multiplications are bigger, the calculations are bigger, so that you need the calculator for this kind of questions. See the sixth question, same kind of HCF and LCM. Let's take HCF first. So in HCF, let me just rewrite this as 2 raised to 0, 3 raised to 5, 5 raised to 1 and 7 raised to 0. I have this habit that while finding HCF and LCM, I write all the prime numbers starting from the lowest one in the ascending order, so that if there are no prime numbers, like there is no 2 here, so I write 2 raised to 0. It makes me it makes it easier for the calculation. So that's 2 raised to 3, 3 raised to 1, there is no 5, so I can write 5 raised to 0 and 7 raised to 4. Now for HCF, let's take the lowest power. So 2's lowest power is 0, 3's lowest power is 1, 5's lowest power is 0 and 7's lowest power is also 0. So it's just that's 3 into, I think there's some mistake. Yeah, this is not 7 raised to 0, that's 7 raised to 3. Come on. So yeah, so this is 7 raised to 3, the lowest power of 7 is 7 raised to 3. So now let's use calculator. So that's 3 raised to 1, that's 3 into 7 raised to 3, 1029. Now let's consider the LCM. For LCM, we take the highest power, so that will be 2 raised to 3, 3 raised to 5, 5 raised to 1, 7 raised to 4. Now for this we need calculator. 2 raised to 3 into 3 raised to 5 into 5 into 7 to the power 4. So that's a big number, huh? 23337720. Clear? So the methods are same like P2, but the calculations will be bigger. Work out the LCM of 36 and 120. That's easy. Let's do the prime factorization of 36. Divisible by 2, 18 divided by 2, 9 divided by 3, that's 3 and 3, 1. 120 divided by 2, you will get 60, divided by 2, you will get 30, divided by 2, 15 divided by 3, 5 and 5 divided by 5 is 1. So 36 is 2 raised to 2, 3 raised to 2, there is no 5, so I can write 5 raised to 0. And 120 is 2 raised to 3, 3 raised to 1, 5 raised to 1. So in LCM we take the highest power, so 2's highest power is 3, 3's highest power is 2 and 5's highest power is 1. 2 raised to 3 is 8, 3 raised to 2 is 9 and this is 5. Let's use calculator. 8 into 9 into 5, that's 360. Clear? See the 8th question. Prime factorization is already given, we are supposed to find the LCM only, but I have this weird habit. Let's write all the prime numbers from the ascending order. So 5 raised to 2, 7 is not there, so 7 raised to 0, and then 11 raised to 1, there is no 13, so 13 raised to 0, and second one 2 raised to 4, 3 raised to 1, 5 raised to 4, there is no 7, so 7 raised to 0, there is no 11, so 11 raised to 0, and 13 raised to 1. Now for LCM we consider the highest power, so that's 2 raised to 4 into 3 raised to 2, 5 raised to 4, 7 raised to 0, 11 raised to 1, and 13 raised to 1. For this I must use calculator, so that's 2 to the power 4 into 3 to the power 2 into 5 to the power 4 into 11 into 13. I have not considered 7 raised to 0 because it's gonna be 1. So this is 12870000. Clear? See the ninth question. In machine has a buzzer that sounds every 50 minutes. Okay. The machine also has a bell that sounds every 80 minutes. Same kind of question we have done, multiple times. Now they are asking you that after 10 a.m. at 10 a.m. they are gonna bell together, they are gonna ring together, but after that at what time they are gonna bell together, they are gonna ring together. So for that, what the time which we are finding, that will be bigger than 50 and 80 itself. Why? Because till 80 minutes the bell is not gonna ring. So whenever they are gonna ring together, it will be more than 80, of course. So this is why we are gonna find LCM. Clear? So for LCM, let's do the prime factorization. So divide by 2, that's 25, 25 divided by 5, that's 5, and 5 divided by 5 is 1. And for 80, it is divisible by 2, 40, 40 divided by 2, 20, 20 divided by 2, 10, 10 divided by 2, 5, 5 ones are 5. So 50 can be written as 2 raised to 1, 3 raised to 0, 5 raised to 2. For 80, it is 2 raised to 4, 3 raised to 0, and 5 raised to 1. So for LCM, we take the highest power, so 2 raised to 4, 3 raised to 0, and 5 raised to 2. Let's use calculator. 2 raised to 4 into 5 raised to 2. That's 400. So after 400 minutes, they are gonna ring together. Now if you can convert this minutes into hours, it will be 400 divided by 60, so that's 6.6666, right? And if I write it in the fraction, I can do it like this: 400 divided by 60. If you cut this 0 and cut it by 2, so this is 3 and this is 20. 20 by 3 r, which is 3 2 by 3 r, right? So that means 3 r, and 2 by 3 r, if you convert it into minute, 2 by 3 is just 0.67, and multiplied by 60, you will get 40 minutes. So 3 hour 40 minutes. After 3 hours 40 minutes, they are gonna ring together. So if you add it in the 10 a.m., you will get 1:40 p.m., right? So at 1:40 p.m. they are gonna sound together. In the time kind of questions, whenever the answer is in time, if the question is given in AM PM format, give the answer in AM PM format. If the question is given in 24-hour format, then your answer it must be in 24-hour format. Keep this in mind, huh? Now 10th question, LCM of 120 and 144. Let's do the prime factorization. So that's 30 divided by 2, 15, 3, 5, 5 ones are 5. And in 144 divided by 2, you will get 72, divided by 2, 36, divided by 2, 18, divided by 2, 9, divided by 3, that's 3, and 3 ones are 3. So 120 can be written as 2 raised to 3, 3 raised to 1, 5 raised to 1. And 144, it's 2 raised to 4, 3 raised to 2, there is no 5, so I can write 5 is to 0. And LCM will be highest power of each factor, so that's 2 raised to 4, 3 raised to 2, 5 raised to 1. Let's use calculator for this. 2 to the power 4 into 3 to the power 2 into 5. So the answer is 720. Clear? I hope it's clear till here. See the 11th question, written as the product of the prime factors, that's 672 is a prime factorization. Write 252 as a product of its prime factors. 252. So 252 divided by 2, it will be 126 divided by 2, that's 63. It's divisible by 3, so you'll get 21. 21 again divisible by 3, so you'll get 7. 7 ones are 7. So this 252 can be written as 2 raised to 2, 3 raised to 2, there is no 5, and 7 raised to 1. Now we are supposed to find the HCF of both of them. So for HCF we take the lowest power. So 2's lowest power is 2 raised to 2, 3's lowest power is 3 raised to 1, and 7 raised to 1 in both. So the lowest power will be 7 raised to 1. 2 raised to 2 is 4 times 3 times 7. 4 3's are 7, 4 3's are 12, 12 7's are 84. So your HCF is 84. Clear? Let's jump to the third worksheet. See the first question, find the highest odd number that is a factor of 60 and 90. First of all, highest common factor will be HCF, but they are not asking you the highest common factor. They are asking you the highest odd factor. Okay, so for this what I'll do, the prime factorization method will not be used here. For this what I'll do, I'll enlist all the factors of 60 as well as all the factors of 90. So for that, let's see, 60, 160 is a 60, and if it is divisible by 2, so yes, 2 times 30 is also 60, 3 times 20 is 60, and 4 times 15 is 60, 5 times 12 is 60, and 6 times 10 is 60. I think it is not divisible by 8, yeah, so 8, it's not, yeah. So all the factors are like this. And if you do the 90, that's 1 times 90, 2 times 45, it's 3 times 30, 4 times, I don't think it is divisible by 4, no, it's not divisible by 4. Then yeah, 5, I think, yeah, 5 said it's divisible by 5. So if you divide by 5, you'll get 18. It is divisible by 6, 6 times 15, not by 7, not by 8, it is divisible by 9, so 9 times 10. So all the factors of 60, so they are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30 and 60. And factors of 90, they are 1, 2, 3, 5, 6, 9, 10, 15, 18, 30, 45 and 90. Okay, now what I'm doing, I'm highlighting all the common factors now. Okay, so you see 1 is common in both, 2 is common in both, 3 is common in both, and 5 is common, 6 is common, 10 is common, 15 is common in both, and 30 is common. Yeah, so if you find the HCF, it will be 30, but they are asking the highest common odd factor. So you see 30 itself is highest common factor, but it's not odd. But 15 is the common factor also, and it is the highest of the odd factors, right? So highest odd factor is 15. So the question is very tricky, huh? Don't jump to, don't jump for finding the HCF. They are asking the highest common odd factor, not the highest common factor. Keep this in mind. Okay, second question. There are three lamps. Lamp A flashes every 20 seconds, B flashes 45 seconds, and C flashes 120 seconds. Three lamps start flashing at the same time. How many times in 1 hour will the three lamps flash at the same time? First of all, we'll find the LCM so that we can get an idea that after how many minutes how many seconds they are gonna light together. We have done this kind of questions for sounding together or buses living together, so you now you must get an idea that this kind of questions they are asking you to find the LCM first and then think about anything else. Okay, so finding LCM of 20, 45 and 120. So 10 divided by 2, 5 ones are 5. 45 divisible by 3, you will get 15. 15 also divisible by 3, you will get 5 ones are 5. And 120 divided by 2, 60, divided by 2, 30, divided by 2, 15, divided by 3, 5, and 5 ones are 5. So for finding the LCM, we consider the highest power. Let's first write all the factors here. 2 raised to 2, there is no 3, so 3 raised to 0 and 5 raised to 1. 45, that's 2 raised to 0, 3 raised to 2, 5 raised to 1. And 120, that's 2 raised to 3, 3 raised to 1, 5 raised to 1. So for finding LCM, let's consider the highest powers of each factor. So that's 2 raised to 3, 3 raised to 2, 5 raised to 1. 2 raised to 3 is 8, this is 9, and this is 5. Let's use calculator. 8 into 9 into 5, that's 360. So after 360 seconds, they are gonna light together after every 360 seconds. Now you see 360 seconds, it's divided by 60 if you do, so that will be 6 minutes. Okay, so after every 6 minutes they are lighting together, and we want to find in 1 hour how many times they are flashing together. For that I am taking one example. Let's take the time of 10 a.m. and starting from that to the 1 hour which is 11 a.m. till then how many 6-minute intervals are coming. So that's 10:06, then 10:12, then 18, then 10:24, 10:30, similarly 10:36, 10:42, 10:48, 10:54, and then 11. So how these many times they are lighting together. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Now what students make mistake, they directly do in 1 hour there are 60 minutes and they divide that 60 by 6 and they are getting 10. So they think that the lights are gonna flash together 10 times in 1 hour, but it's not 10 times, it's 11 times, because you are not considering the time at the starting they are flashing together, so that will be added in the 10. So this is why they are 11 times. Clear? See the third question, LCM of 40 and 56. Let's do the prime factorization. 40 divided by 2, 20, 20 divided by 2, 10, 10 divided by 2, 5, and 5 ones are 5. And 56, it's divisible by 2. You will get 28 divided by 2, 14, divided by 2, 7, 7 ones are 7. So 40 can be written as 2 raised to 3, 5 raised to 0, and 7 raised to 0. Sorry, not 5 raised to 0, it's 5 raised to 1. I'm very sorry. Yeah, and 56, that's 2 raised to 3, 5 raised to 0 and 7 raised to 1. So in LCM we take the highest power, so 2 raised to 3, 5 raised to 1, 7 raised to 1. So that's 8 into 5 into 7. Let's do calculator. 8 into 5 into 7, that's 280. Clear? Now A and B are given in the prime factors, and the product of prime factors, and we are supposed to find the HCF of them. Simple thing, in HCF we take the lowest power. So 2's lowest power is 2, 3's lowest power is 1 because both of them have 3 raised to 1, and 5's lowest power is 1 because here it is 5 raised to 1 and here it is 5 raised to 2. So that's 4 into 3 into 5, that's gonna be 60. Okay, see the fourth question. 720 as a product of its prime factors, divisible by 2 of course, so that's 360 divisible by 2, 180 divided by 2, 90 divided by 2, 45, 45 divisible by 3, 15, 15 divisible by 3, you will get 5, and 5 ones are 5. So 720 is 2 raised to 4, 3 raised to 2, 5 raised to 1. And find the smallest whole number that 720 can be multiplied by to give a square number. Now if you observe the prime factorization of 720, that is 2 raised to 4, 3 raised to 2 and 5 raised to 1. And if you observe any square number, its prime factorization, it has each prime factor power must be even. Each prime factor's power must be even. So here you see 2 raised to 4, it's even power, 3 raised to 2 even power, but there is 5 raised to 1 only. So you will have to multiply something with this to make the power of 5 as even, and others should not be disturbed. Other two factors, 2 and 3, must be as it is. So for that obviously I'll multiply 5 only, because 5 raised to 1 is already there. If you multiply it by 5, you'll get the square number, because if you multiply it by 5, 5's power will become 5 raised to 2. So 5 must be multiplied. Clear? So the note here that in any square number, the prime factors are always in even powers. Clear? Do the HCF of 96 and 120. Let's do the prime factorization. Divisible by 2 of course, so that is 48 divided by 2, 24 divided by 2, 12 divided by 2, 6 divided by 2, 3, and 3 ones are 3. Similarly 120 divided by 2, 60 divided by 2, 30 divided by 2, 15 divided by 3, 5, and 5 ones are 5. So 96 can be written as 2 raised to 1, 2, 3, 4, 5, 2 raised to 5, 3 raised to 1, and there is no 5, so let's write 5 raised to 0. And 120 is 2 raised to 3, 3 raised to 1, and 5 raised to 1. In HCF we take the lowest power, so that's 2 raised to 3, 3 raised to 1, and 5 raised to 0. That's 8 into 3, 24. Now B part, all are given, A, B and C are given in prime factors only, and we are supposed to take the LCM of them. Okay, let me write it again because I have this OCD, sorry guys, but I want to write each and every prime factor starting from the 2, all the ascending order. Yeah, 7 raised to 1, 11 raised to 1, and that's 2 raised to 0, 3 raised to 1, 5 raised to 2, 7 raised to 0, and 11 raised to 0. Now let's take LCM. For LCM we consider the highest power of each factor. So that's 2 raised to 4, 3 raised to 1, 5 raised to 2, 7 raised to 1, and 11 raised to 1. Clear? Let's use calculator for this. So 2 raised to 4, then multiplied by 3 multiplied by 5 raised to 2 multiplied by 7 multiplied by 11. So you'll get 92400. Clear? See the sixth question. This is the last question. So A, B and C all are given in prime factors only. Let me write it: 2 raised to 0, 3 raised to 5, 5 raised to 1 and 7 raised to 3. This is 2 raised to 3, 3 raised to 1, there is no 5, so 5 raised to 0 and 7 raised to 4. And C is 2 raised to P, 3 raised to 0, 5 raised to Q and 7 raised to R. Okay, so here they are asking HCF of B and C is 2 raised to 3 and 7, means 7 raised to 1. Only B and C, if you see, in B and C the lowest power of 2 must be 2 raised to 3, because in HCF we take the lowest power. So lowest power of 2 raised to 3 and 2 raised to P will be 2 raised to 3. That means P is bigger than 3. Clear? Then second thing, 7 raised to 1. Here you see there are two numbers, 7 raised to 4 and 7 raised to R, and they have considered the smaller one as 7 raised to 1. So obviously R must be 1, then only 7 raised to 4 and 7 raised to 1 among all these among these two, 7 raised to 1 will be the lowest power of 7. Clear? So that means R is equals to 1. Okay, now let's consider other two numbers. Sorry, yeah. So other two numbers are A and C. The LCM of A and C is given. In LCM we take the highest power. So for A and C, you see the 2 raised to 0 and 2 raised to P, and they have taken the highest power as 2 raised to 4. This is 2 raised to 0, so obviously this must be 2 raised to 4, then only the highest power will be 2 raised to 4. So here I have written P is greater than 3, so it must be P is equals to 4 only. Yeah, and then 3 raised to 5 is the highest. Yeah, that is visible. Then 5 raised to 1 and 5 raised to Q. Amongst them 5 raised to 2 is the highest one. So obviously Q must be equal to 2, then only between 5 raised to 1 and 5 raised to Q, 5 raised to 2 is the highest. And between 7 raised to 3 and 7 raised to R we have already found, that's 1. So R raised to 7 and R raised to 1. Obviously R raised to 7 is bigger, and they have considered that only. So we have got all these three unknowns. P is equals to 4, R is equals to 1, Q is equals to 2 and R is equals to 1. This was a twisted and very good question. If you didn't get it in the first trial, just rewind the question and do it again. These kind of questions are the most difficult kind of questions you can find in HCF LCM topic. So that was all for today. I know the session was a little bit longer, but I wanted to cover all the important questions here. Till then, just keep practicing, and please subscribe the channel and give me a like and comment below if these sessions are very helpful to you. Thank you very much.